Hello, in this video I'm going to discuss the difference between normalized and device coordinates, also known as screen space coordinates. So if we go to the code, these are the positions of the 3 points that we've drawn. Let's just look at the middle one, which is the first one right here, 0, 0, and 0, 0.0. That should be 0.0. I was messing around with it before. It actually doesn't really matter, but just to keep consistency. The last one is the z-axis. As we're not dealing with anything to do with 3D yet, we can ignore that, but the concept will apply to it when we get to it. Okay, so 0, 0.0, 0, 0.0, it doesn't look like the center because the width of this canvas is 640 pixels. The height of it is 480. So the middle in the x-axis should be 320, and in the y-axis should be 240. It should just be half of that and half of that. But because WebGL and a lot of other drawing, rendering, APIs use normalized coordinates, what that means is it ranges from -1 to 1. 0 would be the center because it's halfway between -1 and 1. And that's the same case for this. There are benefits to that. And one of the benefits is if you put 1, that will always mean, so let's say if it's in the x-axis, for example, if I put 1, as I did over the last coordinate, 1, 1, which resulted going all the way to the right and all the way to the top, it will always mean this is in the top right. Doesn't matter if my canvas is 640 by 480 pixels. Doesn't matter if I jump to some sort of HD mode like 1280 by 720 or 4K like 3840 by 2160. It sort of future proofs it and makes calculations easier, but it can be a bit cumbersome to use. So I want to implement a couple of functions that will allow us to continue using normalized coordinates but use device coordinates as well, so it's a little easier to read. And literally, let's just get to it. So what I want to achieve by the end of this video is if I put 320 here, and in this case, because the height is 480, 240, that should be in the center then, instead of it being, because if I put it now, you can put a decimal, it doesn't really matter because we just want a whole number. You might think it's disappeared. It's not really disappeared. It's just gone really far to the right and really far up. So it's so far away, you can consider it as disappeared. We obviously don't want that. So let's create the functions. The first one we're going to create is going to be called normalized to device. Normalized to device. So this is if you provide a normalized coordinate and it will actually give you the device coordinate. So this is useful if, I'm going to provide both functions. For this video, we're only going to need the one, which is the second one, but I'm providing both, to go either way in case you get a normalized coordinate from somewhere, maybe a function, and maybe you haven't created that library, maybe it's built in or another developer created it, and you want to process it in a pixel form, like you want to not in normalized form. This allows you to convert it. This takes in 2 parameters, chord and axis size. So this is basically if you are trying to position it on the x-axis, it'd be 640 in this case because it's relative to the max size. And the chord is just where you want to position it in device coordinates. First of all, we need to calculate half of the axis size, and that's this right here, divide by 2. So pretty simple stuff. Then we are just literally gonna work out the device coordinate, which equals, it's the chord itself, which range between -1 and 1. We want it not in the negatives if it is in a negative value. So -1 actually refers to 0 in device coordinates. Anything below that refers to an actual negative coordinate, so basically off the screen to the left, and that's fine. You might want to do that, but we want to make sure that -1 is essentially 0 and 1 is 2. So it ranges between 0 and 2. To do that, we just do +1. And once we've got that, we just times it by the half axis size. Then we just return device chord. So imagine if I put in the value 320 as the chord, and then the max axis or the axis size is 640. It would get the axis size and you'll put 320 here, and then what it would do for this calculation, it would do chord +1. Actually, no, that would be 0, sorry, because we do normalized to device. So 0 which should be center. 0 + 1 is, so I'll just do 0 + 1 equals 1. Then it will say 1 times by the half axis size, which is 320, which equals 320, which is halfway. So that's basically how it works. And to do the device to normalize, which is the one we are going to be using in this video, first of all, let's just put this here, and we still need a half axis size. We still need that. We need to get rid of this, otherwise this will cause an error. We're going to rename this to normalized chord now. And instead of doing this, we need to sort of reverse it. So what we want to do is, first we want to do what is happening last, and in here what is happening last is times it by half axis size, so we need to divide it by that. So chord, which would be, you know, like 0, 320, 640 for example, like a regular device coordinate, divided by half axis size, then we want to take away 1. So now make sure there's no errors. So no errors, which is good. Now if we go down here, so we want to put 320 by 240, we just put device to normalize, and remember we need to specify the actual coordinate that we want to position it at in device coordinates, so 320, and it could be 0.0, so you can have that precision as well. Next, what we want to do is, I'll just put it as 320. Next, what we want to do is provide the axis size. So we need 640 for the width and 480 for the height. We can get that from the canvas. So if we do canvas.width, that will produce 640, but that is dynamic, so you'll get whatever, you know, we set in the width and the height. And that could be set in CSS as well. And we just need to set this to height, set this to 240. If I reload, as you can see, no change, so it is in the center. Let me prove that it is working. I want to position this, keep it positioned halfway in the, you know, y-axis, but I want to position it all the way to the end along, you know, in line with this one, but halfway in the y-axis. So usually in normalized coordinates, it'll be -1, 0, 1, so we would put 1. But in device coordinates, it's 0, that's 320, and that's 640. So let's put 640 here. As you can see, it is there now, and it is based on the center point, which, you know, again, you can change at a later date if you don't want it based on center point. If you want to anchor it maybe to the top left, feel free to make that modification. Now let me show you it going down as well. So that should be, instead of 240, it would be maybe 0, because a positive value makes it go up. So 0 should make it into the bottom right. So that is it. I'll reverse it back to this, because this is what I've got on the GitHub page. And yeah, that is it. So that's the difference between normalized and device coordinates. We've got two functions here. This one is the one we used, which takes in a device coordinate, you know, a screen space coordinate, and converts it to a normalized one. So it's just easy to read, and, you know, it allows us to have a bit more precision with what we're doing. The normalized to device coordinate we haven't used, but it just means if you get a normalized coordinate from somewhere, but you want to process it in a device coordinate, you know, fashion, this allows you to convert it. So it's there in case you need it. So that's it. Thanks for watching. If you have any questions, feel free to pop me a message. And as usual, I look forward to seeing you in the next video.